Hey everyone, I hope you are liking, subscribing, sharing these videos. Ozonolysis is an organic reaction where unsaturated bonds of alkene, or alkyne are broken, or even azo compounds can be cleaved with the help of ozone. So what they will give in this process, let's see. So I'll take one example here. Let's say we have an alkene and you're using ozonolysis. So what could be different type of ozonolysis? So first of all, understand there are two type of ozonolysis. One is called reductive ozonolysis, अदर इज कॉल्ड ऑक्सीडेटिव ओजोनोलाइसिस. रिडक्टिव ओजोनोलाइसिस जहाँ पे हम बात करेंगे रिडक्शन मोड में ओजोनोलाइसिस की, और ऑक्सीडेटिव ओजोनोलाइसिस जहाँ पे ऑक्सीडेशन मोड में ओजोनोलाइसिस की. So if you're given any alkene, okay, and you're reacting this with ozone, so what happens basically, it forms ozonide. If you say ozonide structure, so it will be like when you draw the structure of ozone, you can take help of this kind of result, that we are keeping it O double bond O plus minus like this, okay, and this kind of structure we can draw. So once we try to draw the complete structure, it will take this kind of shape, so where this bond is broken and we have presence of ozonide structure like this, okay, this kind of structure we can observe. So we are forming this ozonide structure, and later the same thing cleaves and we get the formation of double bond at this place and similarly double bond at this place, so which is basically oxidation of this part. So what eventually you are doing here, you are breaking this double bond and assigning both the places OO. That will be the simple trick. This is ozonide which is formed, and later we are getting this kind of result which is a carbonyl compound with this case. If it is a reaction which is reductive type, my answer will be correct. And how will you decide that if it is reductive type? Because my answers are not acids, so we're stopping somewhere at aldehydes or ketones, right? So in this case, anyway, it is a ketone and ketones cannot further oxidized. So ketones cannot get oxidized further. Hence, we will stop here in this reaction. Let's say you have been given a question like this and they ask, do the ozonolysis of this compound. So we know that this can break from here, can break from here, can break from here. We can think of its counterpart, which is CH3 at this place, double bond coming to these places. With conjugation, again you can break it like this. So if you try to break this thing, see what kind of groups you're going to get. CH3, C double bond O, and then CHO. This is one part, CHO and CHO. That's the second part. And similarly here, CHO, CHO. What about this case? If you observe this one, it is CH3, C double bond O, C double bond O plus CHO, CHO, and at this place also C double bond OH, C double bond OH. So if we compare, like this part is matching with this portion, and then other units are CHO, CHO units. So you're getting similar kind of answer, okay, because it's completely symmetric. But let's say in place of this structure, if somebody gives us this question where it is like xylene structure and that xylene is ortho position, so CH3 is here and CH3 is here, and the next case you could double bond at this place and CH3s are here and here. So now this type of scenario, if you break the bonds, try to understand, you're going to get different set of products. It will not be the same scenario this time, because this will end up giving you CH3, C double bond O, C double bond OH. Along with that, it will give, what else it will give, let's see. So it will give CHO, CHO, glyoxal which is called, and the last part will be CH3, C double bond O, C double bond OH. Whereas in this case what we're going to get is CH3, C double bond O connected with CH3, C double bond O. So remember, no such answers was available in previous structure of conjugated system. Along with that, we will get 2 moles of CHO, CHO, which is called glyoxal. So any aromatic system is given, you will break like this. Remember, when it is reductive ozonolysis, so any reductive ozonolysis will be done in presence of groups like ozonolysis. They will give you some zinc heating, or they can give you something like DMS, dimethyl sulfide heating. Okay, what is dimethyl sulfide? Is this kind of group. So what will happen? This zinc will get oxidized actually to zinc oxide, and this will get oxidized to DMSO. In the process, the reduction will, or the oxidation of the existing part will not happen. So if you start from this kind of question, or let's say H was here, We will not expect acids, rather I'll expect answer as aldehydes. At the same place, if the question would have been, ozonolysis, okay, in presence and heating and then water is mentioned directly, then my answer would have been OH at this place. So both the answers would have been OH. That's a major difference. So how will you recognize whether reductive ozonolysis is happening? You will see groups like DMS, groups like zinc, okay, they will be present and they are known to absorb the oxygen. Hence my answer will be corresponding to the answers which are reductive answers. So oxidative ozonolysis is these examples. Okay, when you break these things and give the highest possible oxidation state. So I hope you understood the video, what all things we have discussed so far. The same thing when happens for any alkyne, let's say this triple bond. So what happens once you draw the ozonide will have this kind of scenario. So we'll not be able to break this middle bond because this is an extra bond after ozone reaction. So when you try to break it, you'll break this part, you'll break this part, but the middle connections will be as it is. So your final answer would look like this. It will be a di-keto kind of thing, di-keto scenario. Okay. So we'll see later that di-keto things can further be like oxidized by HiO4 or periodic acid. So that will be the next part of discussion. But I hope in this video what all reactions we are talking about, ozone reactions, you understood those reactions. So formation of ozonide and followed by that recovering or getting out of it the oxidized form, we will understand. Thank you very much for liking, subscribing, sharing the videos. Thank you.